Welcome back, class. This video, what I would like to do is just give you a couple of examples of writing out a chemical equation. If you haven't already taken a look at some lessons in the past where you're writing the formulas for ionic compounds and net ionic equations, those types of things, I highly recommend you go back, take a look at those videos, and then come back to this, because you really need to understand how to do that to be able to fully understand this, unless you're a quick learner, which I'm sure many of you are. So with that, let's just go ahead and jump in. So we've got chlorine molecules react with sodium iodide to form excuse me, sodium chloride and iodine molecules. So let's take a look at this. We've got chlorine. So if always make sure you have periodic table with you. So right here we've got chlorine, and we know chlorine is, so right here we have chlorine, and we know that chlorine is, let me get a different color. How about, let's go with this. We know there's chlorine, right? And it reacts with sodium iodide. So you should be able to do this, remembering that sodium is a positive one, forms positive one ions, and that iodine forms the negative iodide crystals. If you're not sure of that, you come back over here, right? And you see over here that here is sodium, and it forms positive one cations, and then we've got the iodine, and we see here that it forms the negative one iodide anions, right? So you need to remember all that. Let's go back to our lesson. So that's how we got this, right? So those things react, all right, to form sodium chloride. And so remember, you've got sodium and then chloride ions. And so remember, the sum of the charges is 0 already. So it's just NaCl and iodine molecules. And so iodine, we know, is that capital I. So now looking at this, here is something that is extremely important. Whenever you see anything, any kind of elements like this that are by themselves, they are not combined with anything else. Until you get used to this, until you learn this on your own, you always want to go to your periodic table, and you'll notice down here that there is an entire list, all right? There's an entire list of what we call diatomic elements. And what that means is that whenever these particular elements are by themselves, there will always be 2 di of those atoms together, all right? So, and you can see here that chlorine is on that list, and you can see that iodine is on that list. And so that means back here in our problem, chlorine is on the list. So that means we have to put a 2 here, and iodine, we have to put a 2 right there as well. Okay? So now at this point, all right, let me get this stuff out of the way real quick. Although we've got plenty of room, I could have left it there, no big deal. So now what we want to do is ask ourselves, is this a balanced chemical equation? So over here on the left side, we see that there are this one chlorine molecule, okay? So let me back this up. What you need to know is, think back to your basic math algebra. Not even really, big time algebra. Every single number that is here, or anything that you can think about, has a coefficient of a 1 in front of it. There's a coefficient of 1 in front of all of these. 1 chlorine molecule, 1 sodium iodide molecule, 1 sodium chloride molecule, and 1 iodine molecule. But 1s are understood, so we just don't write them. So we just leave it blank. All right. Now with that said, now we can come over here and we realize that in this one chlorine molecule, that there's two of them bonded together. So that means there's, if this is a chlorine atom, then there is some sort of chemical bond to another chlorine atom. So that's one chlorine molecule, but there's two chlorine atoms that are covalently bonded here. Okay, that's what that means. So you have to be able to see this in your mind's eye, all right? So, and the same is true over here with iodine. We would say that, there's an iodine molecule covalently bonded to an iodine molecule. And this is just, when I'm drawing this right now, this is just a conceptual picture. This is not the way we really represent it, okay? This is just a conceptual understanding of it, all right? But we would really use like Lewis structures, which we've had in previous lessons, okay? So now, looking at this, you can see that there are two chlorines over here. And remember, these are the reactants. And the arrow always points to the products. We can see here that there are two chlorines and on the reactant side and one chlorine on the product side. Well, we need to get that balanced. So obviously we would have to change this from a 2 or from a 1 to a 2. So now it's like distributive property. So if there's an invisible 1 here, 1 times this 2 would equal 2. 2 times this 1 here would be 2, and so it balances itself out. All right. So now we can see by doing this, there are 2 sodiums. And we see over here that there are 2 iodines already. So we come over here, we add 2 to this, and distributive property, 2 times this 1 sodium would be 2 of those, and 2 times this 1 iodine would be 2 of those as well. And so now we have a balanced reaction. Okay, now this is a balanced chemical equation, all right, for this reaction. All right, and then if we were to classify this, what we remember, we have our 5 classes of reaction. We have synthesis, decomposition, we have a single replacement, double replacement, or a combustion reaction. And so what we do is we look for patterns here, okay? We want to look for patterns. And so we see here that there's essentially one compound here being added to this molecule of a single type of atom. There's 2 of them together, but that's a single type. Whenever that happens, we know that this is a single replacement reaction. Okay? And particularly, when it's a single replacement reaction, we want to ask ourselves one thing. Okay, this is what you need to remember always, always, always for these. Is it cationic or is it anionic? So you remember from previous lessons that anions, these are your negative ions, and cations, these are your positive ions. So with that said, what you do is you look at this molecule here, and that's by itself. And you ask yourself, would it form negative ions or would it form positive ions? So we go back to our periodic table and we come over here to where chlorine is, all right? And we can clearly see that chlorine forms negative ions, all right, the anions. And so we would call this an anionic single replacement reaction, okay? We would call this an anionic single replacement reaction. All right, that's the answer for classifying this particular reaction here. And the reason it's called replacement is because this is what happened. Let me erase that right there out of our way. What really happened chemically was the chlorine comes in here, kicks out the sodium, and now the sodium, oh, I'm sorry, I said that backwards. I'm sorry. Pardon me. I was thinking of a different type of reaction. The chlorine comes in here, and it kicks out and displaces this iodine and pushes the iodine out. So now what happens is if chlorine is there instead, then sodium and chlorine are now combining and interacting together. All right. And then the iodine is by itself, so it has no choice but to combine with itself, which is how we get this over here. All right. So for those of you who might need a different visual for this, I'm going to rewrite this equation. And let me get this out the way, and let me show you a little better visual. If you were having trouble following that, let me show you a little visual that you need to be able to see in your mind's eye to really help you with this. So in a reaction, what would happen would be you would see there would be some chloride ions plus these sodium ions and these iodide ions. Okay, the chloride ions come in here, kick out this iodide, and so now the iodine is by itself. And so now effectively on this side, what we have is sodium ions now combined with chloride ions. And these are all by themselves. And so what happens is they're going to bond together. These things will bond together to form that molecule. And then right here, +1, -1 is already 0. So this is going to combine to form this. This was already combined to form that, and these were already bound together chemically to form those. Okay, this is what's happening. This is what you've got to be able to see in your mind's eye. All right, let's take a look at another example. Okay, so here we have calcium oxide reacting with water. All right, so calcium oxide, go back to our periodic table, and remember there's calcium forms +2, and then oxide lets us know we're dealing with oxygen, so that's a -2 charge on the anion there. So that lets us know that we would have calcium plus the oxide ions. Well, 2 plus a -2 is already 0, so we just bring everything together, so we get calcium oxide. Okay, it's reacting with water. Well, that's pretty easy. That's just H2O. That's pretty easy. And forms calcium hydroxide. So you look up, you see the term hydroxide, and you remember, okay, hydroxide, polyatomic ion. And this will be familiar the more and more you do this. The less you do it, the more difficult it becomes to figure this out. But nowhere on the periodic table would you find the word hydroxide anywhere. Plus, if you look at it, hydro, oxygen. So it sounds like hydrogen and oxygen together, which it is. It's the polyatomic ion OH negative. All right. So if we think about it, we've got calcium plus the hydroxide ion. That's 2 plus a -1. That is not 0. So remember, there's a 1 here. 1 times 2 is 2. There is right now a 1 right here, but 1 times the -1 here doesn't get us what we need. So we would need 2 of those. 2 times 1 is a -2, which is 0, which is what we want for our compounds. The ionic compounds are neutral, right? They carry a 0 charge. So we need 1 calcium and we need 2 hydroxides. So remember, there's 1 and there's 2. All right. So now what we want to do is take a look. Is this thing balanced? All right. Well, we've got 1 calcium here, 1 calcium here. All right, calciums are balanced. We have 2 hydrogens here, and there is there's one hydrogen in this, in parentheses here, but like distributive property, like your math teachers have taught you, 2 times that 1 is 2. So it looks like the hydrogens are balanced. And then let's take a look at the oxygen. All right, so there's an oxygen here and an oxygen here. Well, that's 2, and then 2 times this 1 right here is 2. So we can say that, yes, this is a balanced chemical equation. All right, it's already balanced as it is. Coefficient of 1, coefficient of 1, coefficient of 1. They're understood. So remember, you just don't write them. You just leave it blank. And then we see that we have this plus this, and it's combined all together. And we know that when that happens, that is a synthesis reaction. Okay, so those 5 different types of reactions, you're going to want to get used to looking at the characteristics of them. The only thing that changes are the elements, but you're going to want to get used to the fact that that a synthesis reaction follows this same pattern, that all of your reactants come together into one larger compound. And of course, decomposition would be the reverse of that. All right. Hope this helped, and by all means, please reach out if you need some assistance. Watch the videos as much as possible. Take notes. It's always great learning with you. Have fun doing those problem sets, and I will see you in the next lesson real soon. Bye.